I've taken out the indicator display assembly. I have noticed that down in here above the slider pots there is also a lot of that, or for want of a better word, the fallout from the capacitor exploding and spewing its stuff everywhere, as well as the board that it's on. I can see that some of it has also gone down in here above the fader panels, so that means that when I take this front panel off again, I'm going to have to do some serious cleaning to ensure that there's no damage done down there. Hopefully it's just surface, but I can see the top of a circuit board there and resistors, and it's just covered with the same sort of light brown dust. So unfortunately that's not a good sign, but it should be able to be cleaned. But anyway, first things first, I've got to clean and repair the fluorescent indicator assembly. Right. Okay, I've got these apart now, and I have to try to figure out what cleaning solution I'm going to use. I'm never keen on using strong acids or caustic solutions on these things because they tend to linger. Well, this board is just as grubby as the other one. So whatever came out was a huge cloud of crap, and it's just settled on these two boards, plus down below on top of and behind the faders. So even though it mostly emanated from in here, this capacitor, it didn't actually mark the top side of that board. So only goes to show that it was a cloud of really bad fumes and dust, and it's just settled on the top surfaces. So anyway, it's pretty nasty. Well, I've managed to clean both boards, I think, reasonably well, and you can probably see that all of that brown mist has been removed. How I did it was I got a plastic tray, filled it with roughly equal quantities of white vinegar, water. I didn't worry about using distilled, I didn't think that would matter, and isopropyl alcohol, and a squirt of detergent. I sloshed around with a toothbrush, gave each side a big clean. There was no coils on this, so nothing whereby the chemicals could get inside the windings and destroy it. Everything was sealed packages, except for this board here. There's a potentiometer. I unsoldered that before I cleaned it. After that solution, I then used another tray full of just isopropyl alcohol and water, nothing else, and once again gave it a good sloshing about. The idea was there to try and remove any traces of the vinegar, as vinegar being an acid is not a good idea, and isopropyl alcohol will evaporate to nothing, and water, well, water's water. So I felt that was a good way of rinsing them. Now with this particular one, with the display on the front, I simply just did the circuit board, top and bottom. Once I'd done that with both of them, I then soaked them in a bucket of water completely, sloshed them about made sure that they were as well rinsed as I could possibly make them. Once I'd done that, I air dried them just for a couple of minutes. Then I went out to where my compressor is and blew all of the solution, what was left, away from the boards. With that, I was able to blow underneath the ICs with reasonably high pressure, and the liquid underneath just went away. It went. So it was a really good way of drying the board without waiting for evaporation. And with evaporation, there's always the risk of leaving a residue. These connectors also shoved compressed air down into the pins to clean away any solution that might be hanging onto the contacts. Same reason. And when all that was done, I soldered the variable resistor back into place and actually gave it a little squirt of deoxit, which hopefully will send it on its merry way. This particular board, these are the two capacitors that were faulty. They were both polypropylene, the orange kind. This one here I think had gone short, or 11 ohms, no capacitance whatsoever. That's on the input to one of the op amps, I think. And this one here is a 4700, and these are the two replacements that came with the capacitor kit to replace the polypropylene, and just as well because they were both faulty. I suspect it was the electrolytic itself. It has plus and minus 12 volts across it, i.e. 24 volts, and according to the parts list and the that component should be a 4.7 microfarad 16 volt. Yes, 16 volt with 24 volts across it. So crazy, stupid, no wonder it exploded. Now it's possible that I may be mistaken, but according to the circuit diagram, there's minus 12 on one end and plus 12 on the other. So I have to go by that, and yeah, no wonder. So I'm trying to find a electrolytic to put in there to replace it, and then we'll be good to go. The other little board, a lot of the heat rose and affected a little bit of the wiring here, got a bit charred, so I'm going to add some heat shrink around a couple of the wires. The third wire is okay, the orange one, but the red and the brown one are well, a bit charred. The three transistors that are missing here, there's a whole string of what are they, 2SC733s or something. These got a little bit dislodged and grunge on the pins, so I unsoldered them, which was no mean feat, I might add, and I'll put them back in now. They measured okay according to my ohm meter, so I'll put them back in, and we should be good to go. Right, I'll get back. I've finished with this top board. I've put some heat shrink over two of the wires that were a bit charred, and replaced, or put back in those three transistors. This capacitor is meant to be a 4.7 microfarad across the minus 12 to plus 12, but I haven't got one, and since it's only a supply, I've got a 47 mic, so I'll put that in temporarily until I can get a replacement. Anyway, so now I think I need to put it back together and see if the display works. These are the two looms that come from the display. This one here, the 5-pin goes to the power supply board, and this one here goes to the detector board, which I assume is some semblance of the audio, which then gets displayed on the dB VU meter. So let's put her in. Well, I didn't video it, but I should have. But I just had that electrolytic capacitor that I put in, I just had it explode almost straight away. That only leads me to think that, oh God, yes I did, I put it in the wrong way. Oh, yes I did. I can see a little plus symbol here, but on this side when I did it, it looked to me like the bar was on the on that positive terminal, which would have meant putting the negative of the capacitor there, so I put it in the wrong way. God. Yeah, it made a nice little pop, but half of the display worked for a couple of seconds before it blew up. So that's promising. Now I just got to put in another capacitor and clean up the mess, and hopefully it didn't do any other damage. I don't think so. It just left a bit of a spray of the capacitor in it, so I've got to wash that off now. Might actually use some contact cleaner and spray it. Yeah, I think that did the trick. You can't leave the electrolyte there, it'll eventually corrode. Well, that capacitor in that circuit has a bit of a history. It was blown up, and then I've blown one up. I'll use the air compressor, I'll be back. Well, I didn't find another 47 mic, but I found a 22 mic 63 volt, so that's even better. As I say, the original is 4.7. Well, let's try again. Hopefully not another little explosion like that. It was never seen me go so quick for the power switch. Right. I'm assuming we haven't blown any fuses or anything like that. It didn't happen before, so it probably didn't happen this time. So anyway, we'll find out. Please, no more explosions. Ooh. Okay, well that's looking good. The audio, we should be getting some audio into it. We're missing half the display. Yeah, okay, so obviously there's a fault in here, but at least we've got half the display. That's something. So it's more than likely just an electronic fault. Okay, with well, that's what we've got to find out, but at least we got half the display. That's something. Well, it's doing something. So that's source tape. Yeah, things happening. Okay, it's just not proper. Okay, probably the first thing to do is to find out why half the display isn't working. Oh, well, at least that's progress. But it doesn't seem to do any movement with how loud the music is. It's not making any difference. So, alright, okay, more work to do. I alluded to having a lot of problems with the fluorescent display. I've taken a lot of components off this board, as you can see. Now, that normally sits in there like that and goes in the machine like that. Don't worry about these blue caps. So, half of the display sort of worked, and then occasionally I could get the end where it says LDBR lit up by sort of touching it across like that. So it's very sensitive to any sort of leakage. Or I found though that the logic circuitry is extremely hard to follow. There's no information about graphs or what the logic circuitry should be. I mean, if I wanted to spend 10 months with a logic analyzer working it out, I suppose I could have, but that's not my forte. And in the end, I found a few little things. In the end, I thought I'd just clean the hell out of them, take all the components off, and then I thought, well, okay, well, how cheap are they? So I went through a list of all of the parts, in particular all the logic chips, but they're generally about $1.20 each. So when you add it all up, it's about $30 worth of ICs for both boards. So it's really not much at all. So what I'm going to do is change all of the ICs. However, I'm going to do it in 2 stages. This top board still has, I haven't really taken anything off yet, and so I thought, okay, I'll do one board at a time. It means delays in ordering parts and whatever, but fortunately that's not a big concern. So what I'll do is I'll get some IC sockets for this board, populate it, put the connectors back in, the transistors and whatever, and then put all the original ICs back in and try and fault find it that way, swap things around and so on. Anyway, taking all this stuff off, I did find that the transistor next to the cooked electrolytic was actually faulty. So it could be that might be causing all of the problems, but I'm not willing to put all the ICs back in now and then have to desolder them again. So I'm going to get some sockets. It'll take another week. Everything's by postage these days. And I'll put in a new transistor and the socketed ICs and put it back together with the other board, which is unaltered except for being cleaned. And if the problem goes away, if it's fixed, then it means that I don't really need to touch this top board anymore. So that's the way I'm going to do it. And if I find that it's still faulty, I will repopulate this board with the new ICs and this one with new ICs. But that, of course, will take another week or 2 weeks. So unfortunately, every step is going to take a lot of time. But that's the plan. So it's been put aside for the moment. But it was interesting that I did find one transistor that was actually faulty. So, and it's right next to the burnt cap, so I should have checked it earlier actually, but oh well. That's life. I've numbered all the old ICs and I'll clean up the pins and try them in the socketed sockets when I put them in. So if it works, well and good. If it doesn't, then I can easily swap out these and put in the new ICs that I buy. That's the reason for socketing it. And being on the bottom board, it's not as if the chips will fall out. They'll sit in. I'll get good gold machined sockets, so it should be fine. So it's some steps involved here, but it has to wait. So in the meantime, I thought I'd the fluorescent display doesn't require the rest of the machine to be working, and likewise the rest of the machine doesn't rely upon the display to work. For example, you know, play, fast forward, rewind. So I'll get back to the mechanism and try and ensure that that's all done correctly, etc., and try and source that problem. So, as I've said before, small moves, Ellie, small moves. I shall return.